Bismillah. Welcome to ThinkMath. Today we continue with limits and we are studying a theorem and two corollaries that let us evaluate algebraic limits directly. By the end of this lesson, you will be able to identify the main theorem for limits of the form x to the n minus a to the n over x minus a. Understand and apply two corollaries and solve several word examples step by step. Here's the main result. The limit as x approaches a of x to the power n minus a to the power n divided by x minus a equals n times a to the power n minus 1. This formula is actually the special limit we use later to define the derivative of x to the power n at x equals a, so it is a standard result in calculus, not just a random trick. This holds for every real n where the expression is defined. If you substitute x equals a directly, we get 0 over 0, which is indeterminate. This theorem resolves it immediately. Let's look at an example. We want the limit as x approaches 2 of x to the 5 minus 32 over x minus 2. First, write 32 as 2 to the power 5. Now, numerator is x to the 5 minus 2 to the 5, and the denominator is x minus 2. That matches the theorem exactly, with n equals 5 and a equals 2. So the answer is 5 times 2 to the power 4, which is 5 times 16 equals 80. Next, the limit as x approaches root 7 of x squared minus x over x minus root 7. Write 7 as root 7 squared. Now it is x squared minus root 7 squared over x minus root 7. This is n equals 2, a equals root 7. The answer is 2 root 7 to the power 1, which is 2 root 7. Now a root example. The limit as x approaches 9 of root x minus 3 over x minus 9. Rewrite root x as x to the 1 half and 3 as 9 to the 1 half. The structure is now x to the 1 half minus 9 to the 1 half over x minus 9. So n equals 1 half and a equals 9. The answer is 1 half times 9 to the power negative 1 half, which is 1 half times 1/3 equals 1/6. The next example needs a small preparation step. We have x to the 5 plus 32 over x squared plus 5x plus 6. Notice that 32 equals negative bracket negative 2 to the 5. So the numerator is x to the 5 minus negative 2 to the 5. Factor the denominator as x plus 2 times x plus 3 and rewrite x plus 2 as x minus negative 2. Now the theorem applies. N equals 5, a equals negative 2. We evaluate 5 times negative 2 to the 4, divided by the remaining factor, x plus 3, at x equals negative 2. That gives 5 times 16 over 1 equals 80. The first corollary is the shifted form of the same theorem. The limit as x approaches 0 of x plus a to the power n minus a to the power n all over x is also n times a to the power n minus 1. Here the small quantity that goes to 0 is x itself. We look at this example. We want the limit as x approaches 0 of x plus 5 to the 4 minus 625 over x. Since 625 equals 5 to the 4, this matches corollary 1 exactly, with a equals 5 and n equals 4. The answer is 4 times 5 cubed equals 4 times 125 equals 500. Example 2. The limit as x approaches 1 half of 32x to the 5 minus 1 over 2x minus 1. Rewrite 32x to the 5 as 2x to the 5. So we have 32x. So we have 2x to the 5 minus 1 to the 5 over 2x minus 1. Let t equal 2x, so t approaches 1 as x approaches 1 half. The limit becomes t to the 5 minus 1 to the 5 over t minus 1. With n equals 5 and a equals 1, the answer is 5 times 1 to the 4 equals 5. The second corollary handles a quotient of two power differences. The limit as x approaches a of x to the n minus a to the n, divided by x to the m minus a to the m, equals n over m times a to the power n minus m. We are essentially applying the main theorem to both top and bottom, and then taking the ratio. Let's take an example. We want the limit as x approaches 3 of x to the 4 minus 27x over 3x to the 4 minus 243. Factor out x from the numerator and 3 from the denominator. We get x over 3 times x cubed minus 27 over x to the 4 minus 81. Write 27 as 3 cubed and 81 as 3 to the 4. Substitute x equals 3 for the x over 3 factor. That gives 1. Apply corollary 2 with n equals 3, m equals 4, a equals 3 quarters times 3 to the power negative 1, which is 3 quarters times 1/3 equals 1 quarter. Another example. The limit as x approaches 3 of x cubed plus x minus 36 over x to the 4 minus 81. Notice that 27 plus 9 equals 36. So split the numerator as x cubed minus 27 plus x squared minus 9. The denominator stays as x to the 4 minus 3 to the 4. Split the limit into two separate fractions. For the first, corollary 2 gives 3 quarters times 3 to the negative 1 equals 1 quarter. For the second, it gives 2 quarters times 3 to the negative 2 equals 1/18. Adding 1 quarter plus 1/18 equals 9/36 plus 2/36 equals 11/36. Now it's your turn. Here are 3 practice problems. Pause the video, solve them using the theorem or one of the corollaries, and post your answer in the comments below. I will review the best answers in the next lesson. First problem, limit as x approaches 9 of 9 minus x over x squared minus 81. The second, limit as x approaches 1 of the 7th root of x minus 1 divided by x minus 1. The third problem is the limit as x approaches 2 of x to the minus 8 minus 16 to the minus 2 divided by x minus 2. The key takeaway is simple. Match the structure of the limit to the theorem or a corollary, apply the formula, and simplify. For more lessons like this, visit my website at www.gamalhamid.net. Thanks for watching ThinkMath, and see you in the next lesson.